Hello dear children, hope all are fine. Welcome you to the first module of physics from the chapter Light, Reflection and Refraction. Children, light we know is a form of energy and light is needed to see the things around us. We are able to see the beautiful world around us due to this light. We detect light through our eyes. The sense of sight is one of the important senses that help us to see the beautiful world around us. We see the blue sky, we see the trees, flowers, the organisms, the hills, mountains, we see our beloveds. We learn with the help of eyes. We have to really thank God for giving us this most sensitive organ and let us take care of it. But in this lesson, we have to learn more. We'll be mainly learning about two main phenomena, reflection and refraction. We'll study reflection in plane mirrors that you have studied in your lower classes and reflection in spherical mirrors. Also, we'll understand the refraction through spherical lenses. In this module, we'll be familiarizing the concepts that we studied in our lower classes, especially about reflection and the laws of reflection. So let's start. As we said, light is a form of energy that produces a sensation of vision. Though we see the various objects around us with our eyes, but eyes alone cannot see any object. For example, we enter in a dark room. Though we have eyes, we can't see anything inside that room because we need a source of light to make the objects visible. So take the case of this flower. How do we see this flower? Flower is an object here. So when the light rays from the sun fall on this flower, the flower reflects the light in all directions. The reflected light, when it enters into a person's eye, then that person can see that particular flower. So children, it is only when the light coming from an object enters our eyes that we are able to see that object. So this light may have been emitted by the object itself or it may have been reflected by the object. Light enables us to see objects from which it comes or from which it is reflected. For example, we see the sun because it's emitting light. We see the stars, it is emitting its own light. We see the light from the tube, the torch. The firefly emits its own light. So all these objects come under the category of luminous objects as they give the light of their own. But there are the other category of objects which don't emit their own light but they reflect light. So the luminous objects help us to see the wide variety of non-luminous objects around us. A table, a chair, we ourselves, the book, everything are non-luminous. So objects that do not emit their own light but only reflect or scatter the light falling on them are called as non-luminous objects. So when these non-luminous objects scatter light or reflect light and that reflected light enters into our eyes, we see that particular object. Children, we know that light travels in straight lines. It travels with a speed of 3 lakh km per second or 3 into 10 raised to 8 meter per second. Light doesn't require a medium for its propagation. Light can travel through vacuum. We also studied about opaque objects, transparent objects, translucent objects. Do you remember? Opaque objects block the light that falls on them and hence when light falls on an opaque object, it casts shadows. Whereas a transparent object allows the light to enter through it. So we are able to see through a transparent medium as light is transmitted through it. Whereas the translucent objects allow light to pass through them partially. So all these things we have gone through or we have come across in our lower classes. Children, before we go into the main topic, let us discuss the theories related to the nature of light. The two major theories related to light are particle theory of light and wave theory of light. According to particle theory, light is composed of particles which travel in straight line at very high speeds, and each particle is called as a photon. Sir Isaac Newton was a person to come forward to support this theory with his theory called as the Newton's corpuscular theory. And through this theory, he well explained the phenomena like reflection, refraction, casting of shadows, etc. But he couldn't explain some phenomena. One among them was diffraction. So children, what is diffraction? When light comes on the path of an opaque object, that means the size of the opaque object is very small. So what happens is the light will bend across that object, or it will violate that rectilinear propagation of light. And this phenomena is known as diffraction. And it was not explained by him, so his theory was discarded. And later came the wave theory of light. The scientists like Christian Huygens, they supported this theory, and according to this theory, the light is considered as an electromagnetic wave which do not require a material medium for their propagation. They could well explain the diffraction, interference like phenomena which you'll study in your higher class, but they couldn't explain reflection or refraction. So there was a confusion regarding the true nature of light until there emerged a new theory called as the quantum theory of light. So according to this theory, light exhibits both the properties of waves as well as particles, because we have evidences that light behaves as waves and also light behaves as particles. So the modern theory of light called quantum theory of light combines both the particle and the wave nature of light. We know that the branch of physics that deals with the study of light is known as optics. And so thereafter the optics is divided into ray optics and wave optics. Ray optics, we consider light to be in the form of that means it's made up of particles, or it supports the rectilinear propagation or particle theory of light. Whereas wave optics, we explain everything regarding light as a wave. So children, what is reflection now? The bouncing back of light rays into the same medium after hitting a surface is called reflection. When we throw a ball on a wall, the ball hits the wall and it comes back. The same manner, when light falls on a surface, it is being sent back to the same medium, and that phenomena of light is known as reflection. When we show our face to still water, we can see our face, or the image is seen in water, because the light hits the boundary between the air and the water and it is reflected back to the same medium, that is air. And when the reflected light reach into our eyes, we see our image in that still water. Let us take two objects, a highly polished surface, for example a mirror, and an object, that is a paper. What is the similarity between these two objects, that is a mirror and a paper? Yes, both of them reflect light. What happens when we hold the mirror next to us? Can we see our image in it? Yes. Can we see our image in paper? No. So what is the type of reflection that takes place in a mirror and that of a paper? Children, we are just recalling what we studied in our lower class. A mirror, when light falls on a highly polished surface like as a mirror, it undergoes regular reflection. That means all the light rays falling onto the polished surface are reflected parallel to each other. You can see the reflected rays are parallel to each other. As a result, an image is formed. But in the case of a paper, there are more number of, even though the paper looks smooth, it has lot of irregularities, or it's a rough surface, and so the reflected rays are not parallel to each other after reflection. and so there is no image formation. So let us recall the differences between the regular and the irregular reflection. In regular reflection, all light rays after reflection move parallel to one another. Whereas in irregular reflection, the light rays after reflection are scattered to each other. In regular reflection, images are formed. In irregular, no images are formed. Regular reflection takes place on a smooth surface, whereas irregular reflection takes place on a rough or an irregular surface. So we have to understand that most of the reflection that is taking place around us or in our surroundings are irregular reflections. Children, let us understand the difference between a ray of light and a beam of light. A ray of light is just a concept. That means a straight line path of light is called as a ray of light. You can see there. And what is a beam of light? A bundle of light rays is called as a beam of light. There are different types of beams of light like parallel beams, divergent beam and convergent beam. In parallel beam, you can see all the light rays are parallel to one another, moving in the same direction. In divergent beam, the light rays are getting diverged from a single point to different directions. And convergent beam, you can see the light rays are getting or meeting at a single point and hence called as convergent beam. So these terms, that is the beams, the ray of light, these all will become more familiar to you in the coming classes. Let us draw the ray diagram showing the reflection of light from a plane mirror. You know how to represent a plane mirror. One side we have the coating and the other side is our reflecting surface. Assume a light ray AO that is falling on the mirror at the point O, and let it be reflected and let OB be our reflected ray. So AO is our incident ray and OB is our reflected ray, and ON is the normal that is shown in red. Let I be the angle of incidence, that is the angle that is formed between the incident ray and the normal, and R be the angle of reflection, that is the angle formed between the reflected ray and the normal. So before going into the laws of reflection, let us again familiarize with the terms that we used in our previous ray diagram. Incident ray, the ray of light that falls on the surface or on the mirror surface is called the incident ray. Point of incidence, it is the point at which the incident ray falls on the mirror. Reflected ray, the ray that is sent back after reflection from the mirror is called the reflected ray. Normal, the imaginary line drawn perpendicular at the point of incidence is called the normal. Angle of incidence, very important, angle of incidence is the angle formed between the incident ray and the normal. So in the ray diagram you can see that it is angle AON. Angle of reflection, it is the angle formed between the reflected ray and the normal, that is in the figure it is angle BON. Now let us state the laws of reflection. Laws of reflection. The reflection of light from a plane surface like that of a plane mirror or a spherical surface like that of spherical mirrors like concave mirrors or convex mirrors takes place according to two laws which are known as the laws of reflection of light. Children, these laws you have studied in your 8th standard. So which are the two laws of reflection? First law. The first law of reflection, it states that the incident ray, the reflected ray and the normal at the point of incidence all lie in the same plane. Second law of reflection, the angle of incidence is always equal to the angle of reflection. Let us go through an activity and verify these laws of reflection.
In this lesson, we're going to use a light box to have a look at the law of reflection. The light box shines light out of both sides, but we're going to use the side that produces nice, clean, straight beams. The kit comes with a quadruple ray forming plate, a triple ray forming plate, a fat single ray forming plate, or a thin single ray forming plate, which is the one we'll be using in this prac. The other side of the light box that has the mirrors is useful for studying color. You can mix, for example, red light with blue light, or green light with red light, but we're not going to use the mirror side in this lesson. The aim of this practical exercise is to find out how a light beam's angle of incidence compares with its angle of reflection. To do this, we need to accurately record the path of the light rays and then use a protractor to measure the angles. The instructions are all on the law of reflection prac sheet, but I'll show you what to do right now. Firstly, draw a line on a piece of paper and then place the back surface of the mirror on the line, since most of the light reflects from the back surface. You can see when we get a close-up that the mirror's back surface is on the line, while the glass is in front of the line. Direct the light ray at an angle towards the mirror and mark the path of the incident and reflected rays by placing two small dots on each of them. Using a ruler, connect the dots with straight lines. You can now measure the angle of incidence and the angle of reflection with a protractor, which is best placed like this. The line marked 90 degrees on the protractor will be your 0 degrees, so in this case, the angle of reflection is 35 degrees, and the angle of incidence is also 35 degrees. So, just repeating, when using a protractor in this situation, you have to ignore the degrees marked on it and measure the angle of each light ray with respect to the normal. The angle of incidence in this case is 10, 20, 30, 35 degrees, and the angle of reflection is 10, 20, 30, 35 degrees as well. Once you've measured the angles, you can draw in the normal line and mark in the angles and the direction that the light was traveling in. Do a total of 4 so-called ray tracings, making sure that you vary the incident angle each time, fill in the table, and answer the questions.
Children, hope you recalled the laws of reflection that you studied earlier, and it was more clear through the activity. So the angle that the incident ray makes with the normal will be always equal to the angle that the reflected ray makes with the normal, and always make sure that you take the angle of incidence from the normal. You measure angle of incidence or angle of reflection from the normal to the other side. So here are 2 questions and try to answer. The first, you can see a ray diagram, and the 30 degree is the angle that the incident ray makes with the mirror. So you have to find out what is the angle of reflection. Second question, what happens when a ray of light falls normally or perpendicular? That means it is making 90 degree on the surface of a mirror. So try to answer these questions. Children, now make a note of the notes that have to be written in the notebook. So give a neat heading of the chapter's name: light, reflection and refraction. We copy down the ray diagram showing the reflection of light from a plane mirror, that is in the 10th slide. Neatly make sure you draw it with a pencil. Show the incident ray, reflected ray, and show the direction of the rays using arrow marks. The plane mirror should be well coated on one side. Hope you'll draw it neatly. The second question is the laws of reflection. So statement of, that means the 2 laws has to be written. The homework questions have to be done in the back side of the notebook. So hope you are being cleared with the things or the concepts that we have already studied in your previous classes. Go through it again and keep safe. Thank you.